Okay, I'm continuing off from where I left off on the last video, and I left off in problem 6, part C. It's asking when does the particle move at its greatest speed. So to answer this, I'm gonna use that speed is the absolute value of velocity. So if speed is the absolute value of velocity, and here we're provided with the graph of velocity, the absolute value of this graph here will stay the same from 0 to 3 because it's positive, and when it's the absolute value, positive stays positive, but from 3 to 5, from an interval from 3 to 5, this gets reflected across this t-axis, the horizontal axis. So we get a graph that looks something more or less like this, where on the interval from 3 to 4 it reflects up, and this is the graph of speed, so it's the absolute value of velocity. And you notice that the particle moves at its greatest speed on this interval and at that point there. So the particle moves at its greatest speed on the interval 1/2 to 2 and when t equals 4. And that's problem number 6. Problem 7 and 8 are multiple choice. Problem number 7 is asking, well, you're given a piecewise function, and it says the function f is defined above. For what value of k, if any, is f continuous at x equals 2? So we need to go back to the definition of continuity, and by definition, if a function is continuous, we know that the limit has to exist. So let's check that the limit exists. And remember, the limit will only exist if the limit from the left equals the limit from the right. So the limit of fx as x approaches 2 from the negative side should equal the limit of fx as x approaches 2 from the positive side. So the limit of x squared minus 3x plus 9 as x approaches 2 should equal the limit of k times x plus 1 as x approaches 2. By doing some direct substitution, 2 and for every x, you get 2 squared, which is 4, minus 3 times 2, which is 6 plus 9, and 2n for x here would produce 2k plus 1. When you do some simple algebra, you will get that k is equal to 3. So that makes C the answer. Alright, and finally, problem number 8. So if y equals x times sine x, then dy over dx equals. One thing that you need to understand is that we have a product here. So we have to use the product rule. This is x times sine x. So the product of x and sine x. So this ends up being a simple process. The derivative of x times sine x plus x times the derivative of sine x, which is sine x plus x times cosine of x. That's b. So that's your answer. And that'll be it for this video.